used to measuring angles by measuring the distance between the two arms that form an angle. For instance, when we have two lines separated in this way, we measure the distance between them with a protractor, and so in this case we would measure 45 degrees. Radian measure is similar, but radian measure concentrates more on the distance around the circumference of a circle, or the arc length, as opposed to the distance between the two arms forming the angle. And so when we start with radian measure, we're starting with thinking about the circumference of a circle. If we let the radius of our circle be 1 unit, it makes all of our calculations quite simple. The circumference of a circle with a radius of 1 unit, using the formula circumference equals 2 pi r, is 2 times pi times 1, or just simply 2 pi. So one trip around the circle from beginning and back to the same spot would be a distance of 2 pi if we traveled around the circumference of the circle. That is what radian measure is based on. So we can see that using radian measure, one trip around the circle, or 360 degrees, is the equivalent of 2 pi radians. If we break that up a little bit more, what if we look at this in terms of quadrants, or cutting our circle into 4 equal pieces? If we travel to what we're used to calling a 90-degree angle, then we've traveled a quarter of the way around the circumference of our circle. And so with the circumference being 2 pi r, if we divide that by 4, we end up with pi r over 2, and with the radius being 1, then that becomes pi over 2 radians. So 90 degrees and pi over 2 radians are equivalent. As we continue on around the circle, you can see that 180 degrees is halfway around the circle, and so half of 2 pi is just simply 1 pi radians, and so on. And so now we've accomplished 4 different radian measures as we travel around the outside of our circumference of our circle. If we break that up even a little bit more and we divide our circle into 8 equal pieces, then as we travel around the circle we can add some more radian measures. Halfway between 0 and 90 degrees is 45 degrees, so halfway between 0 and 2 pi radians is pi over 4 radians. If we carry on around the circle, you'll notice that every angle that's equivalent to a 45-degree angle using degree measurements has a denominator of 4 in its radian measure, and that's a good way to remember those. If we divide it up even more, then you can see that we've got our really common angles all represented here on our unit circle. We start at 0, we go to 30 degrees, 45 degrees, 60 degrees, and then 90 degrees. If we have 30-degree intervals as we move around our circle, then all of those radian equivalents will have denominators of 6. So anything that's equivalent to a 30-degree angle with the x-axis is going to have a denominator of 6 in its radian measure. Anything that's equivalent to an angle of 60 degrees with the x-axis is going to have a denominator of 3 in its radian measure, and we've already talked about the denominator of 4 and 2 for the 45 and 90 degree equivalents. It's quite simple to convert between degree measurements and radian measurements. If you have an angle measured in degrees and you wish to switch it over to radians, then you're going to put the number of degrees here and multiply by pi over 180, and now it's converted into radians. If you want to go the other way, you start with radians, then you're going to use the formula at the bottom of the screen, and you're going to multiply the number of radians by 180 over pi, and end up with the value in degrees instead of radians. Now, some of these images I have borrowed from a couple of websites. This website in particular, I took the unit circle broken down into its various radian measures. So you're welcome to have a look at that website also for more information on this topic. If you need help with this topic or any other math topic, please contact me at mathhelp@trentu.ca for an online or an in-person appointment.